Hello everyone and welcome to the Math Bender. I'm Adnan Zaidi and in this session we'll discuss selections with arrangement. In the previous sessions we've talked about what selection is as well as what arrangement is separately, but selection and arrangement together we'll try to see some of the questions where there will be selection as well as arrangement. You may want to look at these lectures before continuing on with this. So let's start. So selection as well as arrangement means that if, let's say, if you are having an election for a head girl, a head boy, and some chairpersons, so every position, selection on every position matters to every person that is being selected. In another example, you could look at the Olympics medal. So there are three types of medals: gold, silver, and bronze. So let's say there are 5 people, and out of which one of them has to be given gold, one silver, and one bronze. So all those 5 people would want to attain gold in the first place, silver in the second, and bronze in the third. So as you could see that every place has its own distinction over others. So this is where arrangement matters. We can see many examples of arrangement when password is concerned, where let's say if my password is 12345, someone tries to put my password as 54321, that won't qualify for it to be correct. The reason being that there is a certain place where one has to be. So every position has to have its importance. So let's try to look at some of the examples here. So how many even numbers less than 500 can be formed? Now remember that when we talk about even numbers less than 500, it did not mention it has to be a 3-digit, so it can be 3-digit numbers. It can be 2-digit numbers, and it can be 1-digit number. So for 1-digit number, there could be 2 possible numbers only. It could be 2, it could be 4. These are the only 2 1-digit numbers which are even and less than 500. So we'll say that the total is 2 here. Let's look at 2-digit numbers and even. So for it to be even, it can be 2 here or 4 here. So if any out of these two, 1 digit comes here, so I'll write 2C1. Out of these two, I'm selecting 1. And then if 1 digit comes here, there is a possibility that out of those 4 individually, one by one, can come here. So 4C1. So there's going to be 4 times 2, which is equals to 8. There are 8 combinations for 2-digit even numbers less than 500. Now let's look at this example here. So for even number to be less than 500, here can be either 2 and here can be 2, 3, 4. It cannot be 5, because if 5 comes as the first digit, then it will exceed the 500 number. But now if you see this one, then for it to be even, there could be 2 here and 4 in the last blank, and 2, 3, 4. Now as you can see that there's an overlapping. 2 and 4 can be overlapped in both of these places. So to be on the safe side, we rather fix one number and then vary the other one. So for 3 digits, let's fix here 2 and write or. Or means an addition, and then fix 4 here. Now we are relaxed that this 2 cannot move and this 4 cannot move here. So now for this place, there can be now 3, 4 and 1. So 1, 3, 4 can come here. So it would be 3C1 times with, out of those three, now since 2 digits are placed in those 2 blanks, now we are left with 3 digits and we are to fill in one more. So it will be 3C1. So 3C1 times 3C1 is 9. For the next one, if I've placed 4 here, so there could be 1, 2 and 3 that can come here. So out of those 3, one digit will be chosen for that one blank. Since 2 digits are filling first and the last digit, then this center one could be again 3C1, which is 9. So total here is going to be 9 plus 9, 18. So total number will be 18 plus 8 plus 2. 28 ways, where less than 5 digit, it will be 500, less than 500 and even number. Let's look at more practical example of password related. Now there's a security code, and for a security code, place of any character matters. So it has to be a 6 digit. So first step, let's try to construct these 6 digits. So 6 character password, and now out of these 3 are letters, 3 are numbers and 2 are symbols. So when there is no restriction, so out of 3 and 3, 6 and 2, 8. So it will be 8. Out of 8 characters, we are selecting 6. Now remember that selection not only matters here, but shuffling as well. So whichever 6 characters are placed in it will be shuffled as well to give you every possible way a PIN code or a password could be. So it should be 8 C6 times 6 factorial 20160. Although a lot of people may look at this with P, it's as same as 8P, 8C6, but I myself consider to be only restricting to C's, when C's concept of C's is choosing and factorials is shuffling. So merging both of them gives you 8P6. So rather confusing yourself, you can stick to C's only. The security code starts with a letter and finishes with a symbol. Now, it has to start with the letter and finishes with a symbol. So out of those 3, there is going to be one letter, and out of those 2, there's going to be one symbol. Now, in the middle spot, there could be 4 characters. And since one letter comes here and one symbol comes here, there's still, out of 8, 6 characters remaining. So I'll choose 6C4. Not only choosing, those 4 letters can shuffle as well, times with 4 factorial. I'm not shuffling these 2, the reason being that if these are shuffled, then there will be a possibility that instead of letter there could be a number, or vice versa. So this is going to be 3 times 6C4 times 4 factorial. So 6C4 times 4 factorial times 2C1 is 2. This gives you total of 720 ways. The 2 symbols are next to each other in the security code. Now let's look at this part. Now, this statement in itself states that the 2 symbols have to be in that security code. So let's place them straight away rather than choosing. And then rest of them, how many digits? So we have to fill in 4 more, and we have options of 6 characters remaining. So for choosing, I have to choose 4. So out of 6C, 4. I've chosen 4 characters in those 4 slots. So now I have 6 overall, times with 2 factorial for those symbols to be shuffling within themselves, times with 1, 2, 3, 4, 5. 5 factorial for it to be shuffling. Remember, all meant together, we did a case study in permutations. It is as same. So 6C4 choosing them times 2 factorial, which is 2, times 5 factorial, which is equals to 3600. Okay, let's look at this one. 6 books are to be chosen from 8 different books. So all 8 books are different and we are to select 6. So it's as same as 8C6. So it gives you 28 ways where you can select them. Now, a clock is to be displayed on a shelf with 3 of the 8 different books. So let's say there's a clock here. And there are 3 books on each side. Find the number of ways. Now, as you could see, that there is now selection out of those 8 books, and then as well as shuffling, because all of those 8 books are different from one another. So on the shelf, they are arranged in whatever manner. You have to note down all the possible ways. So since there is no restriction, the books can be any on any side. So it could be, out of 8 books, I'm choosing those 6 blank 6 books times with 6 factorial. So which gives you 8C6 times 6 factorial. This gives you 20160. 3 of the books are music books which have to be kept together. So let's say there's a clock here, and out of them 3 books are music books and they have to be together. So let's try to take them separately. So can I say that these 3 music books can be this side, or if the clock is here in the center, the music books can be this side. And the question in itself says that it has to be there. So for the first one, I can write there's 3 musical books shuffling within themselves, which is 3 factorial, times out of those 8 books, 3 of them are already in the shelf, which are music books. Then we are left with 5 books and we are to choose 3. So times with 5C3 times 3 factorial. Selecting those 3 books out of 5 and then shuffling with those 3 as well. It could be either way. Plus, if the music books are on this side of the rack, could be this way as well. So it's going to be as same as the upper one, 5C3 times 3 factorial. Another way, you could have written it as like this as well. 5C3 times 3 factorials times 3 factorials times 2. It will be as same as if you add both of these values. So these were some of the examples where selection as well as arrangement was in play. This is all about permutations and combination. I will come up with a new session on A-level related questions, S1 related questions. So that will be purely for S1. For additional mathematics, it's up till here. Until then, see you. Take care. Bye.